Alright guys, hello and welcome to another GregSowell.com class. This is going to be Mikrotik VPN. This isn't obviously going to be the end-all be-all, but I'm going to try and pack in as most of the most common scenarios as you'll see. And there's actually one scenario in there I'm just going to touch on. I'm not actually going to configure because I'm trying to keep it down time-wise. But you'll see most everything else, and I'm going to try and talk about how to troubleshoot a little bit of this stuff and all the rest of that good stuff too. It kind of goes along with it. So, getting started. What is a VPN? A VPN is virtual private networking, is what that stands for. It's basically a way to send internet across, or rather send traffic across the internet from one site to the other securely, right? And so most often you're going to see this used as in I've got two offices in disparate locations, and I want to secure data communications in between the two. So I can do like RFC 1918 address space on the inside and have that go from one to the other without actually having to NAT to a public IP. RFC 1918 is going to be your private address and your 192.168 stuff, your 10, your 172.16 up to 172.32. If you want to really delve into that good stuff, you can hit this Wikipedia link right here. And that's usually how I go to, because they're going to have a lot of really good information in there. So what this is really going to cover is, a little bit touching on client-based, but then mostly touching on LAN-to-LAN. The difference between client-based is a client is going to be like your PC. You're a teleworker, you're out somewhere, a remote worker, and you connect to the VPN with your PC. That's what I'm going to be considered a client connection, whereas a site to site is going to be from one router to the other router, creating a tunnel in between the two. That way you don't actually have a special piece of software running on your PC to get this encryption going. So here's our basic diagram. We're going to start with PPTP, which is going to be your your client-based connection. As you can see here, we've got your Mikrotik router, just 192.168.1.1 on the inside. Here's a PC, a web server, public IP 1.1.1.1, and for site 1 throughout the rest of the diagrams, it's going to be referencing site 1's going. This is basically site 1 right here. That's what you're seeing. And then out here on the internet is where your clients are going to be located, and they're going to be connecting in. And so let's see, a couple of notes on PPTP. It tunnels all traffic. That's not like a super intelligent option where you can do split tunneling, or say I want from my client, after I connect, I want this stuff to go through the tunnel, this business related traffic, and then I want everything else to go out my regular internet connection, just go to the internet. You can't really say that. It's an all or nothing kind of thing. You can't really pass a lot of options back to the client. It really is easy because it's built into every Windows OS, as well as, you're going to see it on Mac and pretty much any Linux implementation. PPTP apparently offers no encryption unless you're using MS-CHAP version 2, and then it's not the strongest thing out there. So let's go ahead and look at enabling PPTP. I'll do it on my 750 because he's site 1. I've already pre-configured, the IP addressing information to try and help speed this stuff along. So you go to the PPTP server, you're going to enable it. You see max MTU is set right there at 1460. What the MTU is, maximum transmission unit. It's the largest size that a single packet can be to traverse this link. On routers, if the MTU of your packet is larger than the MTU of that routed interface, what it'll generally do is it'll drop that packet because the MTU of your packet you sent is too large, and then it'll send back a special ICMP that says, hey, readjust your MTU to this level, and it'll give you something lower. That way your traffic will still be able to traverse that interface. Well, in a switched infrastructure, whenever a switch sees a packet over the proper MTU size, it just drops it. It black holes, hits the bit bucket. So whenever this stuff is going to go over the internet, 1500 is usually the max you can get away with anywhere. But if you send a 1500 byte packet, what's going to happen is this PPTP is going to add some extra overhead to your packet, and so it's going to bump it up a little bit, and so it'll be over that MTU size, which means it'll get dropped in transit. So the idea is you set your MTU down lower to allow the packet to get encapsulated and still make it through without getting dropped. And so this is default setup. I'm just going to leave everything default. We did that, so now PPTP is running. That's as hard as it is. If you're doing some special firewalling, you're going to need to make sure to allow that PPTP traffic in through your firewall. Let's see. Then you're going to need to add users. And doing it the first way is just to add them. We'll say GregSowell, that's me. Password test. Service, I'll say PPTP. Local address. Now what local address is for every PPTP client, you can have the same local address if you want. So 192.168.1.10 we'll say is the local address. Remote address will be 192.168.11. The remote address has to be different on every one of them. And then you can say OK. And now all you have to do is set up the PPTP connection in Windows and go to town. You should be able to connect right clicked, went to properties, and said new connection. New connection wizard popped up. Go workplace VPN, virtual private networking, company name, we'll call it site 1. Do not dial the initial connection. This was 1.1.1.1. Next, do not use a smart card. Finish. And then I would just put in my name, GregSowell, and password test, and it'll connect me right up. That's all it takes for a Windows PPTP connection. So let's see, so that's kind of the manual if you wanted to add individual users over and over. I mean, it'll still work. It'll work fine that way, but a little bit more dynamic. If you're if you're only gonna have a few PPTP users, that's probably the easiest way to do it. If you're gonna end up with kind of a large pool of them, what you can do is you can go IP pool, and you're gonna set up a new IP pool, and we'll call it PPTP. Addresses, we'll say 192.168.1.11 to 192.168.1.20. So that'll give us 9 addresses. Okay. And then we'll go over here to profiles, default encrypted. Let's see, remote address is what we want to set that pool to. We'll say a local address is always going to be 192.168.1.10, and we'll say OK. And then under the secrets tab for our users, instead of specifying local address and remote address, all that good stuff, profile, we'll use default encryption for there because that's the one I just changed. So now anytime a user connects, it'll check their profile, and in their profile I had set local address as 1.10, just the same as I would if I added them individually secrets. Only this time I set remote address to that PPTP pool under IP pool we just configured. So now as users come in, they'll dynamically get a new remote address out of that pool. So it saves us a lot of trouble of having to statically assign those guys. Plus, if we ended up on those remote addresses, we wanted to keep our pool from 11 to 20 anyway, and we started overlapping those IPs. That meant if 2 of those users with the same remote IP ever tried to connect, it would brick. The second user wouldn't be able to get in. So this way, it's dynamic. It'll grow and shrink kind of as people need it, and it's really the easiest option. I did have in there also that you could enable radius authentication if you want to, if you're running radius, and it'll work with that guide too. So let's see, we got the PPP secret, went over that. doing the pool, PPTP with radius, none of the secrets. Yeah, you just hit the PPTP authentication and hit the checkbox. PPTP and proxy ARP. This is another one that can hit people sometimes. The idea being, let me scroll back up to our diagram. Here we go. Here's our Mikrotik, right? And so whenever somebody comes in PPTP, I've connected to the Mikrotik. Here I am. I'm right here. I'm connected in. Let's see if I switch this to the hand. Yeah, you can see my hand right here. So I'm connected in. What this does is it creates a virtual interface, a PPTP interface that I live on right here. And if my virtual PPTP interface is in the same subnet as that Ethernet 2 interface is right there, which it is because we set up our pools and our local addresses to be in that same subnet, that means they're technically on two physically separate, even though it's more of a logical interface, they're physically separate interfaces on running the same subnet. So if we don't have proxy ARP in, whenever that user connects and they want to ARP for one of those servers' IPs, it'll look on its local subnet, which is its virtual interface right here, and it won't see them, so that'll fail because it'll never be able to resolve the IP down to the MAC address. But what proxy ARP does is it takes that ARP request and it'll go ahead and proxy it through the router to this other subnet. So my request will see the web server. It'll hit that web server. The web server will respond properly and it'll come back to me, right? So it'll complete that. Otherwise, it would never leave that single physical subnet. It's kind of the same way as that web server wanted to hit my remote address. He would proxy. It would only go on this one L2 segment. It wouldn't actually get to me. So this way, it'll actually proxy through. So what you'll need to do is interface. Ethernet 2 is where that subnet lives. ARP, and you can set it to proxy ARP right there, and then just hit apply, and that'll get you rocking and rolling. So now when people PPTP in, they'll still be able to hit those resources on the inside and those inside users. Let's see. Alright, so now we're getting into IPSec, and I'll get to that logging here in a second. I'll go ahead and talk about IPSec first. Excuse me. So IPSec, the two methods we're going to be showing here are tunnel mode and transport mode with IPIP tunnel. Let's see, tunnel mode. Whenever you're using tunnel mode, it's going to use fewer system resources. It's going to have a single layer of complexity. So tunnel mode is just doing an IPSec tunnel. That's all it does, right? Now you come down here to IPSec transport mode with IPIP tunnel. That creates an IPIP tunnel, much like if you're in the Cisco world, kind of like a GRE tunnel. It's just a logical tunnel that's going to do some encapsulation, send it across, that uses IPSec to encrypt that IP traffic, right? So the IP tunnel that gets created, the IPIP information is what actually gets encrypted going across that link. It uses more system resources, again, because it's doing IPSec and an IPIP tunnel, right? Increases complexity because you've got, again, IPSec with an IP, so you're adding an extra layer of complexity in. Now, obviously, well, not obviously, but often, whenever you add complexity, you get some benefits back. It's going to allow for dynamic routing protocols like RIP, which I don't recommend, but OSPF I do recommend. You can do OSPF through there. It's going to allow your multicast traffic to pass, which is why OSPF works, because it communicates with multicast traffic. And it allows for multiple WAN connection failover, as well as easier routing. So if you've got 200 sites doing IPSec, right? And the hub site is where everybody's going to bounce through, which would mean if you add a 201st, that means you have to go out to every single router that you have. We're talking about doing tunnel mode. You'd have to go to every single router and add an extra subnet to go to the head end, and also from the head end coming back, you have to allow that other subnet as well. So you can see that would get really cumbersome. Now, if you're doing an IP to IP tunnel, and so you're doing dynamic routing in there, whenever you bring that 201st site online, as soon as OSPF comes up, that's going to share that route with the hub site. The hub site's going to then propagate that route out, and so now everybody can route to that new site automatically. You don't have to go in there and touch every single device and do troubleshooting. So you can see how it cuts down on the amount of work, just the administrative burden that's involved in this. Now, if you've got say 3 sites, even 4 sites, in your whole organization, I would say just do an IPSec tunnel mode, because it's only going to take you maybe 5 minutes, 10 minutes, to actually configure those settings in the router for each site. So it's not that big a deal. So it's going to lower the complexity. There's a fewer number of things to go wrong, kind of thing. If you've got just a huge volume of sites, obviously the IPIP tunnel is going to be the method to go for. So getting down into it a little bit more, there's 3 parts to creating IPSec connection. Peer is going to be phase 1. Creating IPSec connection is actually a 2-part. The phase 1 connection, it actually they negotiate some encryption protocols to use to set up phase 2. So they'll do it phase 1. They'll do an initial encrypted little session between the 2 devices, and then it'll negotiate phase 2, which is actually going to be your IPSec. It's going to be the completion of your IPSec. The proposal portion is going to be what encryption settings you use for phase 2. So it's really phase 2 will call upon the proposal, or in Cisco the transform set, to determine what security they're going to use in phase 2. Yeah, we just talked about that. You just want to make a match on both sides. Phase 2 security, make a match on both sides. As you can see here, here's the proposal. That's what we're calling it. Now if you're doing tunnel mode in the actually, let me step back here in the peer. This is where you're going to set up your phase 1. You put the IP address of the peer. Generally most of the stuff you can leave default pre-shared key. Go ahead and put in the secret. You can put in your username here. Main mode, send initial connection. Yeah, you want that. NAT traversal, I would say always leave that unchecked. I've had more trouble come of that than good. It's usually best just to leave it default. Diffie-Hellman group. And there's a nice little chart which I will include in the slides that show you which Diffie-Hellman group the matches in the Mikrotik world over to like the Cisco world, in case you're going to go device to device. But yeah, again, just try and make the settings match on both sides. Here on the policy, which is going to be your phase 2, source address, this is going to be where you specify the interesting traffic. I'm going to talk about interesting traffic in a little bit. This side heading to the remote side, protocols you want to go through. Encrypt is what you want the action to be, because you want this to be encrypted traffic. This other stuff we'll talk to when we get there. Tunnel mode, if you want it to be tunnel mode, you check it. If you want it to be transport mode, you leave it unchecked. SA source is going to be generally your public IP, your public WAN IP on your router, and SA destination is generally going to be their public WAN IP proposal. Again, that's going to be what encryption you're going to use for phase 2, and that's set in the proposal section right here. And again, you just want to try and make everything match as best you can. So let's see. Alright, so I told you I would skip back to this logging section. And I highly encourage anybody first setting up their tunnels to get this enabled on your device. I'll go ahead and do site 1 right quick. So let's see, it's going to be system logging. And you just hit the plus, down, you only have to go down 1 to IPSec. I want to go to memory. Say OK, that way when I open the log, you'll actually be able to see IPSec stuff pop up in here. So that's it's a great troubleshooting tool. So Mikrotik to Mikrotik, here we go. Site 1, which is going to be our 750, and Site 2, which is going to be my RB150 that I have over here. Private at Site 1, it's 192.168.1. Site 2, private is 192.168.2. So that's what we're going to try and encrypt between. So let's see here. This is Site 1, so I'm going to go IPSec. I'll go ahead and start with the peer because that's phase 1. 1.1.1.2 is my remote guy. Test is going to be my passwords for everything on this. And I'm just going to leave that all default right there. Now I'm going to configure the policy. And I'm going to say I want 192.168.1.0/24. My side, anything 192.168.1.0 heading to 192.168.2.0/24. I want that to be encrypted. That's what we're considering interesting traffic. Interesting traffic, I'll go ahead and talk about it now. There's a slide for it, but I'll go ahead and talk about it now. Interesting traffic, is anything that is supposed to, in a policy, traverse an IPSec tunnel. So that's anything interesting for the IPSec engine is going to be interesting traffic. So that's what you specify in your policies. So I'll switch over here to action. I'm going to tunnel this good stuff. SA source is 1.1.1.1 because that's my WAN. His is 1.1.1.2. See proposal, I'm just going to leave it default. That should be triple des SHA1. It's a default policy. Diffie-Hellman group 2. Alright, and I'm going to go to IP firewall, and I'm going to go ahead, not filter, we want to go to NAT. I forgot to add this in here, 192.168.1.0/24. So generally when you're going to go to the internet, you're going to masquerade like that. That's generally how you're going to look right off the bat. I got 192.168.1.0, so anybody on the inside trying to go to anything on the outside, go ahead and masquerade. Now the problem with that is anything we want to go through that we want to traverse this tunnel. So if we want 192.168.1.1 to traverse this tunnel, pop out here and still appear to be sourced from there, we have to bypass that natting. Otherwise it'll try and go through that encrypted tunnel natted. Right? Or it might NAT before it actually hits the encryption engine, which would make it never be interesting traffic. Right? So what we're going to do is we're going to add another NAT role. So we're going to say 192.168.1.0 because we only have one site here. And I'm going to cheat. I'm going to be lazy. I'm not going to be too specific. I'm going to say 192.168.0/16. So that's going to say going to anything that's 192.168. And then order of operation is very important, so you're going to drag it to be at the top. Oh, and the default action is accept, and that's what we want to happen. We want to just accept it, which means it'll just, if it matches this, it just stops. It stops completing these rules, which you would understand if you watch the security class. So we've gone ahead and taken care of that, so now we need to go over to this side to Site 2. IPSec. So we're going to start with peer, add 1.1.1.1. Secret is test, shared secret. We're leaving everything else default. Policy, go ahead and add 192.168.2.0/24. So anybody on my private going to 192.1.1.0/24, going to his action, we want to tunnel that good stuff to 1.1. Alright, so we've got it set. So now we should be able to watch for the tunnels to establish. Now, why isn't the encryption engine taken off? Why isn't it trying to establish any tunnels? right now? And the answer is because there's no interesting traffic attempting to traverse the tunnel. So until there's a need for it, it won't actually establish a tunnel. So what we're going to do is we're going to be tools, ping. I use this quite often. You're going to say, since we're at site 1 here, we're going to say 192.168.2.1, which is site 2, and we're going to specify interface 2, which is the one on our side that's the private, that's 192.168.1.1. So what this is going to do is we're going to ping to site 2's private via site 1's private, because this will make it be sourced from Ethernet 2, which will make the pings appear to come from 192.168.1.1. If we just said any and we tried to ping it there, it would go out the outside interface and assume, or rather be sourced from that WAN IP. So it'll be sourced from 1.1.1.1, which is not interesting traffic, which means it would never traverse the tunnel. So we're telling it to come from 192.168.1.1, which is going to appear to be interesting. So if we have everything set up right, you should see the first few packets get rejected, and then it should establish, and as it did there, and you can see that we have good traffic moving across, man. That's the way it works. You hit the log over here, because remember we enabled IPSec Logging. You can see where it kicked off. Engine picked up. Let's see. This is where it actually started the establishment. So if we had any problems in here, if you know, the phase 2, the proposals didn't match, it'll actually tell you in here that the proposal didn't match. Let's try that. I'm going to leave that ping running. I'm going to say proposal, and I'll go ahead and change this to say MD5 installed SAs. I'll go ahead and flush those guys out. Flush them. Now let's hit our log. See? Initiate new phase 2 negotiation. So it completed phase 1, hit phase 2, fatal, no proposal chosen. So the proposals didn't jive. Change that back from MD5 to SHA1. Say OK. I'll go ahead and flush those guys again just to get things moving a little bit faster. Flush. Packet rejected, and then boom, reestablishes. So as you can see, enabling the logging can help you a lot, because it can give you a lot of answers about why something's not working, especially when you're going from Mikrotik to another vendor's device. It can be invaluable. It really can. So we did your standard phase, or rather your standard Mikrotik to Mikrotik, single subnet connection. Let's go ahead and skip all those boring slides. Yeah, again, we talked about interesting traffic and how you can source it. So Mikrotik to Mikrotik with multiple subnets. It's much the same. We'll just go to site 2 and IP address. I should already have it in there. Yeah, I already have it in there. 192.168.3.1 Ethernet 3. So for policy, we'll just add another one. Or rather, what I'll do is I'll cheat. I'll open our existing one, just say copy, and I'll say anything coming from 3, go into 1, action, and encrypt that good stuff. And then over here on 750, I'm going to say same thing. Copy, open it, copy. Anybody coming from 1 going to 3? Alright. 3. There you go. And it goes through the tunnel. Easy peasy Japanesey. Let's see. That was an easy one. Alright, this is the one that I don't feel like disconnecting everything for. Just because I'm lazy. So in theory, the way this one works is, and a lot of wireless ISPs will do this. They hand you the IP they hand you is a private IP, and it's generally static. It's DHCP, you know, but they're doing DHCP reservations, so you get the same IP every time, right? So my private IPs eventually NATed somewhere to a public, you know. So my private IP always stays the same, and it's eventually NATed to the same public IP every time, right? So how do you actually establish a connection? So Site 2's got the private IP, Site 1 still has the public. Now Site 2 is going to NAT to 1.1.1.2, you know, when it's all said and done. But on my Mikrotik right here, it's 10.2.2.2. So I'm going to come into my 150, which is going to be Site 2, you know. And so that was actually going to come to the peer is going to be configured the same. Site 2, this is Site 2, this is the one that has the private IP on its public interface. Policies, this is where it changes. My SA source, instead of being what he's eventually NATed to, I'll make that what it's actually on my WAN interface. That's what you need to change that to. Okay? So in all your policies, that's what you're going to do. For Site 2, the guy with the private. That's the only thing you change on him. Okay? And then over here on Site 1, what you're going to do is you're going to create a new peer. So you can actually, this would be gone. I'm just going to disable it now because we're going to reuse it to save us time later. But it would be gone. So what you would do is you'd create a 0000 person test password. And what that basically says is any IP that wants to connect to me, use this policy. And I would say generate policy, you know. Okay. Over here on policy, these wouldn't exist either. Right there. So that's all it takes. So whenever that remote user, you know, they can be coming from any IP address, connects to me, everything should establish just fine. Just on Site 2, policy, action, SA source needs to be the private, 10.2.2.2, and then on Site 1, you need to have a generic 000 peer with generate policy checked. That's all it takes. So I'm going to go ahead and disable that. Moving on. Cancel that. Mikrotik to Cisco router / ASA. These aren't that bad. They can get a little wacky. Let's see. So on this guy, the only thing I'm going to change, let's see, Site 1. The only thing I'm going to change is the proposal. I'm going to go ahead and use MD5 for funsies, just to mix it up. I went ahead and left perfect forwarding secrecy as Diffie-Hellman Group 2. Yeah, I've got my NAT bypass just like normal. All right, here's the code that you're gonna want to punch in on your router here, and I'm actually gonna cable my router up. Give me just a second. Switch port 1 over to him. So let's see. Here we go. Here's your phase 1 stuff right in here. Here's your transform set, which is going to be like the profile. Here's a shared key. You're specifying it here. See, MD5 triple des, and here we're doing MD5 triple des, keeping them both the same. I'm going to set the peer's IP, perfect forwarding secrecy group. Transform set, specifying it there. Match address kitchen, because I'm actually in my kitchen making this class. Kitchen is going to be what is considered interesting traffic, that access list. And over here you can see I have an extended access list that says the private addressing heading to Site 1. And then you can see that I'm setting up natting in here too. I'm doing NAT overload on the Ethernet interface, like you would in a normal, just a normal site. So let me see here. Most everything else should be in here. So I'm going to go ahead and put this in a little at a time. Let's make sure I'm plugged into them. There we are. Alright. As you can see, we're getting those messages kind of interrupting us. So what I'm going to do is console 0 logging synchronous. Logging synchronous command, what that basically does is if I'm typing on a command and a message wants to pop up, it won't interrupt my line. It'll actually pop the message and then bring my line back, so I won't lose any of my characters and like halfway through a message kind of freak out. That really annoys me. So let's see here. So here's our site 1. We got MD5 triple des. Installed SAs, everything's clean. Let's see, tools, ping. Let's try and throw some interesting traffic across the link. Stop. First, let me ping 101.2. Yeah, okay. The other side's up. Alright. Let's check our config real fast and make sure we got everything in there. Nothing errored out. Triple des MD5 pre-share keys test 1011. Triple des MD5 pair 1 2 remotes performance kitchen. Got our crypto map in there. Alright. So let's look at our peer real quick. 1.1.1.2. Pre-share test main. Triple des MD5. Policy. Ah, there we are. We disabled both of our interesting traffic policies. So let's go ahead and kick that one back on. Tools. Ping. Ping away. Oh, stop. Helps if you put the right IP. 68.2.1, which is going to be specify Ethernet 2. Just packet reject. Come on, there she goes, and it established. So over here on the router, SA. There you go. QM idles, which you're looking for. That means the tunnel's established and working. And as you can see, we're moving traffic across. Not too bad at all. Now, while I'm thinking about it, if I wanted to see the IPSec traffic on here, like debug on this guy, what I would do would be to do a, if this was like a SSH or telnet, I would do terminal monitor, and then it'll actually show me the the messages to the screen. But I don't have to because I'm consoled right in, so I'm going to do debug CRYSA. And so if there were any IPSec messages that needed to come through, they would actually pop right there. And I should be able to flush these guys and make it reestablish. You can see the packets rejecting there, and then over here you can see all the IPSec messages going through. I'm going to do an unall that undebugs everything. Old school shorthand for it, or you can just do you know, up or up to get to the debug, control A to get to the beginning, and say no, and it'll knock it off that way too. Okay, let's see. Here we go. Talking about the troubleshooting. Doing it with the ASA. You can do it command line, which I provide at the end of this, or you can do it through ASDM, which is Cisco's preferred method, which is out of the lips of their top ASA TAC guy. He's actually one of the guys that this guy I heard speaking. He was actually one of the guys that writes some of the questions and actually grades some of the CCIE security stuff. So this guy really knows his stuff, and he wasn't a very nice guy. Let's just say that. Let's say firewall. What I'm just going to do is I'm going to go to wizard, and I'm going to do IPSec VPN. Oh, yeah. Let me move it over to, because we're done with the router now. Now we're doing the ASA method. Let me plug him in. Alright, got him hooked up. He should get going by the time we're done. VPN interface is going to be outside, and it is a site-to-site. Peer address is 101.1.1.1. Pre-shared key is test. We're doing triple des MD5 to family group 2, indeed. Triple des MD5. Local networks, we're going to say, I love this triple dot trick. Click it. Use the network name. So easy. Remote network is 192.168.1.0/24. I love how you can use slash notation again. Exempt to pick host network from address translation. So this is going to do a bypass, a NAT0, excuse me, on the inside interface, which is what we want. And finish. So let's see here. Let me flush this mess out of here. Packet rejected. Ooh, we're getting a failure. Let's see why. What does the log have to say about it? Attribute has been modified. Let's do a quick debug. So the easiest thing to do from your ASDM is monitoring, logging, enable logging. Okay, super view. And usually what you do is right up here you just type in 192, or rather you type in the public IP of the other guy, 101.101.1. To see what's going on. Let's see. Receive encrypted packet with no SA. Matching. Okay. Let's take a look. Back to configure. That's going to be our problem. Had my default route wrong. Alright, there we go. Ugh. After all that trouble. So, as you can see, our tunnel established. You're not seeing anything responding because it's the ASA firewalls blocking the traffic. But check over here in our real-time viewer. You can see that it actually was created. Phase 2 completed. Excellent. I rest my case. Sorry about that. Bum default route. Forgot to put it in properly. So we're done with our ASA. And you saw a good use of the debugging and the real world action and all that good stuff. So, moving on. Walking you through all that good stuff. Mikrotik to Cisco ASA. IP parameters, yeah, setting the identity. Alright. Mikrotik to Cisco router, multiple subnets. Let me hook my router back up to the Mikrotik. There we go. So multiple subnets is actually pretty easy building on our other one. I'm just adding an extra entry to that ACL. Copy. Which is basically going to be the additional subnet that we want to go across. 3.0 is going to go across over to this guy. So let's see, 750, there you are. Come back into our IPSec. Peer's still a good policy. Let's kick this guy back on. Now on the Mikrotik side, what we actually have to do is in the action change it from require, which is default, to unique. Anytime you're doing multiple ACLs to this, multiple policies to the same peer, and the same peer is gonna, or that opposite peer is gonna be a Cisco device. You have to do unique. One of the requisites for Cisco is that each entry, each policy has its own unique SA, which is what that basically tells it to do. Create a new SA for each policy. So we should be able to. Still got those old SAs in there. Let me flush those guys. Flush them. Should go away. Should packet reject and then a net. Should go ahead and establish here in a second. Of course, it's going to be ornery. Install. Let's see, proposals. 75. Let me go ahead and clear that out. Okay, now let me go into the Mikrotik and clear out his. Oops, missed the button. Flush. Got it. MD5, triple des, that's still good. Peer 101.1.2. Yeah, nothing changed in their policies. Let's see. 2 unique. Unique. Make sure I didn't futz anything up. Triple des MD5. Triple des MD5. There's no SA and it's not an initialization offer. Let's see. Both those interfaces are up. As you can see, I'm actually using loopback interfaces. I'm using an 836, and he doesn't actually have anything but 4 port and then like this ISTM BRI interface. So if I just configure loopbacks, it's an easy way for me to get those IP addresses in here. Let's see. Still got the route in there. A lot of times if you're having difficulties, you can just clear, or rather disable it, and it will allow your peers and your policies if flushing doesn't do the trick for you. But I'm just going to do it the lazy way because this isn't production, and I'm going to reboot it. And you can see my interface came back up. So I should be able to go ahead and connect to that guy. Let's see, IPSec, and whoops, tools, ping 168.2.1. I want to source from our inside interface. Phase 1, begin identity protection mode. And there we go, established. So had we just disabled the policies in the peer and then re-enabled them, it probably would have worked, but I'm just lazy. And let's try 3. Boom, there we go. So we got both of them working. And the trick was to add a single ACL entry to our router. And over here on this guy, we made our policies level unique. There you go. So let's see, what did we have next in the list? Alright, Mikrotik to Mikrotik with IPIP tunnel using IPSec. So what this is going to do is we're going to create an IPIP interface on each of our Mikrotiks. As you can see here in the diagram, give them 172.16.11 30-bit subnet, and on site 1 and then .2 on site 2. We're going to create this IP to IP tunnel, and then we're going to encrypt it with IPSec. IPIP actually creates a little virtual tunnel that it's going to take that IP traffic and encapsulate it inside of and send it through, and then we'll use IPSec to further encrypt the traffic, so make it unreadable from point to point. So let's see here. Let's jump over here to site 1. And we're going to go ahead and disable. We'll leave the peer. Stop. So what I'm going to do is first I'm going to go to interface. I'm going to add our IP to IP interface. I'll name it tunnel 1. Local address is going to be our local WAN address, 1.1.1.1. Remote's going to be the remote WAN address, 1.1.1.2. Man, creating tunnel interfaces are so difficult, aren't they? And then on site 2, we're going to do the same thing. IP tunnel, name him tunnel 1 as well. His WAN address is 1.1.1.2. 1.1.1.1 is site 1's WAN address. Okay. Now I'm going to say IP address. I'm going to go ahead and assign his address to his interface, 172.16. 1.2. That's going on the tunnel 1 interface. Let me jump back over here to site 1, IP address 172.16.1.1, ES30-bit, put that on tunnel 1. There we go. So now I'm going to try and ping across that IPIP tunnel first. So 2.16.1.2 should be the far side. Let's make sure. Oh, whoop. Let's just say any. You can see we're trying to transmit across it. Oh, I know what the problem is. Helps if you plug in the Mikrotik. I still had my Cisco router plugged in. So let's give those guys a second to come up. There they go. Now you can see those pings starting to pass. There we go. So we've got our IPIP tunnels back up. Or rather, we've got them established now. Which means we're passing traffic. Now we're passing traffic across that IPIP tunnel, but it's not encrypted. Something to note. Now when you're first getting these set up and troubleshooting, you want to add one layer of complexity at a time. So we have the tunnel established because we can ping the other side of it from site 1. Right? So what I want to do now is route some of our private traffic through it. So I'm going to say IP routes. I'm going to add a static route. You can do this dynamically, but since we're just doing this in a little, like as in with OSPF, but since we're just doing this small lab environment, I'm just going to use static routes. So I'm going to say 192.168.2.0/24 is available via 172.16.1.2, which is going to be the far side of that IPIP tunnel. So what I'm basically telling my Site 1 Mikrotik to do is, you want to get to that private subnet over, in Site 2, then you need to go through this tunnel interface, and next hop through this tunnel interface. So I'm going to say OK. Then I'm going to go over to Site 2. I'm going to do the reverse IP routes. I'm going to say you want to get to 192.168.1.0/24. You're going to need to go through 172.16.1.1, which is the other side of the IPIP tunnel from Site 2. Say OK. So now I should be able to ping 2.168.2.1 through that tunnel interface. Let's see where you at interface. Open it up, traffic. You can see my pings are going right through that tunnel interface. So the IPIP tunnel is working. My ICMP traffic is going through there. And just for fun, let's add an extra route for that second interface routes. You don't technically have to do this, but I'm going to go ahead and do it for fun. Where are we at? We're at Site 1, so I'm going to say 2.168.3.0/24 is also out 172.16.1.2. There you have it. See that traffic's going across the tunnel. So now we know that we have IPIP tunnel established between the two devices. As in, right here, we have this IPIP tunnel established, and we're able to send our private addressing across. So we know that's working, right? That's step 1. Now let's go ahead and try and add the IPSec encryption on top of that. So I'm going to go to Site 1, stop. close some of this good stuff out. So don't need to mess with the routes anymore. Don't need the interfaces anymore. Addresses, we've got all that established. So we've got our remote side, our remote peer, still configured the same. I did, however, change that proposal for the Cisco stuff, so I'm going to change that back. Policies. Here's where it gets interesting. We're going to add a new policy under General, the source address 1.1.1.1, destination address 1.1.1.2. I'm going to go ahead and say encrypt everything. Traffic. Now we're leaving tunnel unchecked. 1.1.1.1 going to 1.1.1.2. So what are we doing here? This didn't change for us, the SA source and destination. We did say use transparent mode by not checking the tunnel check mark. But here in the general, we're saying traffic that's moving, that's generated from the router, you know, us going to their router, there, go ahead and encrypt it. So we got that new policy on. So then I'm going to go to Site 2. Not worried about the routes. Not worried about the address list. Don't care about the interfaces. IPSec. So I'm going to go ahead and disable that old stuff. Our peer is still in there from earlier. Nothing's changing on him, so we're going to go ahead and add our new policy. This one's going to be 1.1.1.2. This router going to 1.1.1.1. The other router. Action. Encrypt require. Tunnel. It's none checked, so we're doing transport mode 1.1.1.2 to 1.1.1.1. Alright. So we should be able to, from Site 1, Tools, Ping. So that should be the IPSec tunnel establishing. That's why it's getting timeouts, and then boom, our traffic's passing through. So our IP to IP tunnel is established because we already verified that earlier, and now our IPSec encryption is going. Tools, IP tunnel. As you can see, it's moving through the IP tunnel. So what does this tell us? This tells us that we can run anything we want. All we have to, through this tunnel interface, all we have to do is route it. Go ahead and stop that ping. Move back over here. So all we have to do is route this traffic. So no longer do we have to create an additional policy every single time. We don't have to create any more policies. We don't ever have to touch the peers. We don't have to do anything with IPSec from this point forward with these IP tunnels if we want to encrypt traffic from this site to this site. No matter how many subnets we add here, no matter how many subnets we add there, you want those additional subnets to go through. We don't have to touch IPSec anymore. We don't have to touch IP to IP anymore, the tunnel interface itself. All we have to do are create routes on these local guys that say go through the tunnel interface. So anything we ever create here and we want it to go through that tunnel encrypted to the far side, we just add a static route that says go to this next hop 172.16.1.1. So in addition to that, you can see that if we were running a dynamic routing protocol like OSPF, and these guys were peered, say via Area 0, and you know, they're communicating completely, they're converged. If I add a new subnet on this router here, you know, and throw them into that OSPF process, it's automatically going to tell that route over here to the second MikroTik, and so then these guys will automatically start routing to that subnet through the tunnel. So you can see the power of that. You know, say we have Site 1 is the hub, and we've got 40 other sites just like Site 2, and they're all OSPF. As soon as a new site comes up, OSPF communicates to the hub site. The hub site then tells everybody else. So everything dynamically moves through those tunnels. We don't ever have to go back and touch the tunnel interface. We don't have to go back and touch the IPSec. We don't have to do anything. It just works, right? So you can see there's a lot of power in that. Also, say there were two WAN interfaces over here at Site 2, and you were going back to Site 1. You would create another. Say the WAN interface over here was 2.2.2.2. You the second one, you'd create another policy that said 2.2.2.2 going over here to encrypt it, and then you'd set up a new peer from here to there. And so if this link ever failed for some reason, it could fail over to the secondary link and go that way. So you can see that you can not only run multiple WANs, you can do dynamic routing. I mean, it's a really great option. It really does. It offers a whole lot of flexibility. So now, another cool trick is you can do it to a Cisco router. You can do the IP to IP tunnel just with a little kind of change in configuration on both pieces of gear. Cisco works pretty well. I've seen in use. Just from Mikrotik OS version, it can kind of have a few quirks here and there. But for the most part, it seems to work pretty steady, and from most of the people I've talked to that do it, they've had pretty good success. So let me hook up the router, Cisco router. Hang on a second. Plug you in. Here we go. So I'm going to go ahead and configure the router. You have to change, because we're also going to do transport mode here on the Cisco device. So I'm going to go ahead and manipulate my transform set so it has transport mode. I'm going to add an extra route for our traffic to go through the IP to IP tunnel. And here's the IP tunnel configuration, or rather IP tunnel ACL. Now I'm going to change the crypto map to use that new ACL. As you can see, I'm being lazy. I'm not changing too much of anything else. I'm just changing the ACL that's actually specifying that interesting traffic. And you can see I'm specifying just IP and IP. Let me create that tunnel interface real fast. And we'll call him tunnel 1. 72.16.1.2, I believe he was. 252. Let's see. Tunnel source should be 1.1.1.2. Tunnel destination should be 1.1.1.1 because that's where we're going. And tunnel mode should be set to IPIP. That should be everything we need to get that initial connection up on this side. Hang on a second. Up. Okay, good deal. Over here, I'm going to say on 750, I'm changing IPSec because this is site 1. Let's see. Right here on the protocol, I'm changing it to IP encapsulation. So that's going to grab just the IP to IP information. Everything else should be fine. Nothing else is changing. Still tunnel mode. Our peer is still the same. Proposal, though, remember for our Cisco stuff, we're doing MD5. Triple des on everything, so that should be good. Let's make sure we don't have any lingering SAs, and we have a whole bunch. Let's get those guys out of there. Let's go ahead and disable our peer. disable our policy. Okay, let's re-enable our policy. Enable our peer, because generally in the real world you're not going to be swapping all these devices out and doing all this crazy stuff, so you're not going to run into this kind of kitschy stuff where it sticks. So let's try and ping across our tunnel. As you saw, I didn't actually do the test where you create the IPIP tunnel and then you do the IPSec on top, because I was lazy. But generally in the real world you're going to do the IPIP tunnel first, and then you're going to make sure that's up and pinging across, and then you're going to do the IPSec encryption across. But as you can see, I went ahead and put everything in place right off the bat, and it's working great. So let's see, interface. Again, as you saw, I disabled the peer and policy and then re-enabled them both, as opposed to rebooting it this time, just to show you that you can do that. So as you can see, tunnel interface, this ICMP is actually going across him, and everything's going across encrypted. So let's see what else we have in here. I do believe we're just about at the end. IPSec dead peer detection. This is actually really useful when you're going to a Cisco device, be it router or ASA. I've used it on both with great success. What this means is 750, okay. Close your interface, bye-bye ping. Peer. On the peer here, if I scroll down just a little bit, there you go. DPD, interval, and max failure. As you can see, by default it's disabled. But what you can do is dead peer detection. You can set that usually like 15 and then like 2 intervals. So what happens is, if the peer is unresponsive, you know, for this number times this number of failures, what it'll do is it'll clear, like if I accept that, and the peer's unresponsive for that amount of time, what it'll do is any of these installed SAs for that peer, it'll actually clear them out and then reestablish, which is phenomenal because that fixes so many Cisco problems that I've found for one reason or another. It was really an amazing fix. I was so pleased that they put that in there to add the DPD, because Cisco already does it for the most part. Let's see what else. NAT traversal, like I said, it's there if you absolutely have to use it, but don't ever do it if you don't. I mean, if there's no other way around it, don't use it. Resources, same resources always put in here. Link back to myself, of course. Cacti Easy, a great monitoring tool. I can't stress monitoring tools enough. How useful they are, especially Cacti, because it's just bringing everything in to one house. You know, all your sys logging, your SNMP traps with a new plugin that's really great. Your NetFlow. Plus just being able to graph everything. Generally when I roll into organization, the first thing I do is install Cacti just to get a grip on their monitoring, you know, find out exactly what's happening where, when, and why. Plus it's free, always helps. If you guys like this video, I know there's a lot of rambling. This was actually turned out to be a lot longer than I thought it would. I'm going to leave in most of that troubleshooting, I think, just so you can kind of see the processes I went through. Checking everything. Again, like any of the other videos, if you like them, please drop me some feedback, because again, I'm not charging for these things. All I'm asking for is a little feedback. Good luck. Be sure to document, or rather comment, all of your firewall rules, your NAT rules, anything you can in the Mikrotik OS. Add a comment to it. That way, it helps out the support guys. Thanks and bye.